There is a place on Earth where the sun has never risen, a place where darkness is permanent, pressure is deadly, and ordinary machines would collapse like empty cans. A place so deep that if Mount Everest were placed inside it, the tallest mountain on Earth would still be hidden beneath the waves. This place is not on Mars. It is not beneath the ice of an alien moon. It is not in another solar system. It is here, on Earth, at the bottom of our own ocean. It is called Challenger Deep, the deepest known point on Earth, hidden inside the Mariana Trench in the western Pacific Ocean. And what makes it so mysterious is not only its depth, it is the fact that this place belongs to our planet, yet it feels almost completely alien. At Infinite Science, we often look upward toward stars, galaxies, black holes, and distant worlds. But today, we are looking down past the waves, down past sunlight, down past the reach of ordinary submarines, down into a world of darkness, pressure, silence, and strange life. Because the deepest place on Earth may be stranger than space itself. The Mariana Trench lies east of the Philippines and near Guam. From above, the ocean looks calm and ordinary, but far below the surface, the seafloor drops into one of the most extreme landscapes on Earth. Within this trench lies Challenger Deep, reaching nearly 36,000 feet below sea level. To understand that number, imagine Mount Everest. Everest rises more than 29,000 feet into the sky. Now imagine placing that entire mountain inside Challenger Deep. Even then, Everest's peak would not reach the surface. There would still be more than a mile of water above it. That is not just deep, that is almost beyond imagination. But the journey to Challenger Deep does not begin with darkness. It begins at the ocean's surface, where the world feels familiar. There is sunlight, waves, fish, birds, boats, clouds, storms, and warm air. The surface ocean is bright, noisy, and alive. But as you descend, everything changes. The first thing to disappear is color. Water absorbs sunlight unevenly. Red fades first, then orange, then yellow. The deeper you go, the more the ocean turns blue, then gray, then black. Soon, sunlight becomes too weak for plants and algae. Below that depth, there are no forests, no grass, no coral reefs glowing in tropical light. There is only darkness. And this darkness is not like night on land. Night ends. The deep ocean's darkness does not. A fish living there never sees sunrise. A microbe in the sediment never sees the moon. The seafloor at Challenger Deep exists in a blackness older than human civilization. But darkness is only the beginning. The deeper you go, the more the pressure rises. At sea level, your body experiences 1 atmosphere of pressure. You do not feel it because your body is built for it. But underwater, pressure increases quickly because more and more water is stacked above you. At Challenger Deep, nearly 7 miles of ocean press down from above. The pressure there is more than 1,000 times greater than at the surface. For a human being without protection, that pressure would be instantly fatal. For ordinary machines, it would be destructive. A normal camera housing would fail. A weak metal container would collapse. Anything with trapped air could implode. This is why the deep ocean is so hard to explore. Space is dangerous because there is almost no pressure. The deepest ocean is dangerous because there is too much pressure. In space, a spacecraft must keep pressure in. At Challenger Deep, a submersible must keep pressure out. Space threatens you with vacuum. The deep sea threatens you with crushing force from every direction at once. That is one reason the deepest ocean can feel stranger than space. Space is empty. The deep ocean is heavy, and that weight never stops pressing. The Mariana Trench formed because Earth itself is restless. Earth's outer shell is broken into enormous tectonic plates, and these plates move slowly over time. Sometimes they pull apart, sometimes they slide past each other, sometimes they collide. The Mariana Trench was created by subduction, a process where one tectonic plate is forced beneath another and sinks into Earth's mantle. In this region, a dense oceanic plate bends downward, dragging the seafloor into a deep trench. So Challenger Deep is not simply a hole in the ocean, it is a geological boundary. It is a place where Earth is recycling its crust and pulling part of its surface back into the planet's interior. To us, the trench looks silent and still, but geologically, it is part of a slow, powerful machine. It is Earth reshaping itself. For most of human history, this world was unreachable. Ancient sailors crossed the oceans, but they had no way of knowing what existed miles below their ships. The deep sea became a place of imagination, fear, and myth. In 1960, Jacques Piccard and Don Walsh entered Challenger Deep aboard a deep-diving craft called the Trieste. Trieste was not a normal submarine, it was a bathyscaphe, designed for extreme depth. The men sat inside a small pressure sphere, protected from the crushing ocean outside. Their descent took hours. Imagine sinking through darkness, hour after hour, knowing that no rescue could quickly reach you. Above you, the surface gets farther away. Around you, the water becomes black. Outside the vessel, pressure grows stronger with every passing minute. During the dive, an outer window pane cracked. At that depth, a crack is not a small problem. It is the kind of sound that could make anyone wonder whether the ocean is about to destroy the vessel instantly. But Trieste survived. Piccard and Walsh continued downward until they reached the bottom of Challenger Deep. For a brief moment, humans had entered the deepest known place on Earth. More than 50 years later, in 2012, filmmaker and explorer James Cameron made a solo descent to Challenger Deep in the Deep Sea Challenger. Cameron traveled alone into the abyss. No crew beside him, no sunlight, no familiar landscape, only instruments, darkness, and the knowledge that he was entering one of the most hostile places on Earth. When he reached the seafloor, he found a world that looked almost alien. No forests, no reefs, no large animals moving through sunlight. Just pale sediment, darkness, silence, and a landscape that seemed removed from ordinary Earth. But Challenger Deep is not lifeless. That may be the most astonishing discovery of all. Life exists there. Not giant sea monsters or prehistoric creatures waiting in the darkness, but smaller, stranger organisms adapted to extreme conditions. Scientists have found microbes, tiny crustaceans called amphipods, sea cucumbers, and other deep-sea life forms surviving at incredible depths. These organisms live without sunlight. They endure crushing pressure. They survive in cold water with limited food. Their existence forces us to rethink what life can tolerate. On the surface, life seems tied to sunlight. Plants use sunlight. Algae use sunlight. Many food chains begin with photosynthesis. But in the deepest ocean, sunlight does not exist. So life must find another way. Much of the deep ocean depends on food falling from above. Scientists call this material marine snow. It is made of dead plankton, waste, tiny particles, and organic debris drifting slowly down from the upper ocean. To us, it may seem like almost nothing, but in the deep sea, it can feed entire communities. Sometimes, a much larger source of food arrives. When a whale dies and sinks to the ocean floor, it creates a whale fall. A single whale carcass can support deep-sea life for years. In the darkness, a dead whale becomes an island of energy. But some deep-sea ecosystems are even stranger. Around hydrothermal vents, life can be powered not by sunlight, but by chemistry. These vents release hot, mineral-rich fluids from beneath the seafloor. Microbes use chemical reactions to create energy, forming the base of a food chain. That discovery changed biology. It proved that life does not always need sunlight. Life can exist in darkness if another energy source is available, and that idea reaches far beyond Earth. Scientists believe some moons in our solar system may have hidden oceans beneath icy crusts. Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, are two of the most fascinating examples. Their surfaces are frozen. Their oceans, if present, are dark. But if they contain water, chemistry, and energy, could life exist there? Challenger Deep helps scientists ask that question. When we study Earth's deepest ocean, we are not only studying our planet, we are studying the possible limits of life in the universe. The creatures of the deep sea may be clues to what alien life could be like. Not intelligent beings building cities, but microbes and small organisms surviving in darkness, pressure, and chemical energy. And yet, despite its importance, we have barely seen the deep ocean. Mapping the ocean floor with sonar is important, but mapping is not the same as seeing. A sonar map can show the shape of mountains, trenches, valleys, and ridges, but it cannot show every organism, every behavior, or every chemical process happening in the sediment. To truly explore the deep sea, scientists need cameras, sensors, robotic vehicles, landers, and submersibles. Every piece of equipment must resist darkness, cold, saltwater corrosion, and crushing pressure. This is why Challenger Deep feels stranger than space. Space is distant, so we expect it to be alien. Mars is supposed to look unfamiliar. Jupiter's moons are supposed to seem mysterious. Black holes are supposed to challenge our understanding. But Challenger Deep is part of home. It is on the same planet where we build cities, grow food, and look up at the sky. It is closer than the moon, yet it is so hostile that only a small number of people have ever reached it. At the bottom, there is no sky, no horizon, no sunlight, no wind, no stars, only darkness pressing in from every direction. When astronauts go into space, they can look back and see Earth glowing below them. At Challenger Deep, there is no view of home. There is only black water, sediment, pressure, and silence. And still, life is there. Tiny organisms move through the sediment. Microbes process chemicals. Particles fall from above. The planet continues its hidden work. Entire ecosystems live and die in places humans almost never see. That is one of the most humbling truths in science. Life does not need our attention to exist. The ocean covers most of Earth, but we are land creatures. We live on the edges of the sea and mistake the surface for the whole story. But beneath the waves is another world. A world of mountains taller than anything on land, trenches deeper than imagination, volcanic ridges stretching across the globe, and animals adapted to conditions that would destroy us instantly. Challenger Deep is the doorway into that world. We often dream of exploring alien oceans on distant moons, but before we fully understand those worlds, we still have an alien ocean here. Before we discover life beyond Earth, we may need to better understand the strange life already hidden in Earth's darkness. Before we say our planet is fully known, we must admit that much of it remains unseen. The deepest place on Earth is not just deep, it is cold, it is dark, it is crushing, it is alive. And it is waiting for our cameras, waiting for our machines, waiting for our questions, waiting to reveal secrets that have been buried beneath the ocean for millions of years. So the next time you look at the sea, remember this. You are only seeing the surface. Far below the waves is a world without sunlight, under impossible pressure, where life survives at the edge of what seems possible. A world closer than space, but in many ways, even stranger. This is infinite science, and the deeper we look, the more mysterious our world becomes. If you enjoyed this journey into the hidden side of Earth, subscribe to Infinite Science for more stories about space, life, and the mysteries science is still trying to solve. Because the universe is not only above us, sometimes the greatest unknown is right beneath our feet.